is telling steady state, but he has given switches K1 and K2. In steady state, after closing K1 alone, the charge in capacitor C1 is 0. Only that switch K1 is closed. So let's get into the part. Option A will check it. K1 switch K1 is closed, and at steady state. Let's get into circuit here. So this is the 12 volt and there's no connection and the switch is closed. Let's have this, and we have the other switch will be open. K2 is open. K1 is closed at steady state. K2 is open. 6 ohm, 12 ohm, 12 volt, 3 ohm, 6 ohm. C1 is 2 farad. C1, C2. Look at the capacitor. There'll be one capacitor that will be connected from this branch to this particular thing. So let's bring that also. C1, C2, C3. Huh? Okay, symbols. C2. This C1. Even a steady state, what should be the current, where the current will flow? Where all capacitors are open circuit, that naturally. So again, the same circuit will appear. Then wait, it's an open circuit. Yeah. So this will be C1, C2, C3. So this 12 volt is parallel. So this will be 18, 12 by 8, 1.5 ampere here. Nine ohm, so 12 by 3, 4 by 3 ampere here. And that will combine here. Charge in capacitor C1 is 0. What about the charge in these capacitors? Let's get into the how these capacitors are. They're connected across this, or they're connected across cell. No, so what would be the charge in them? Will be non-zero. V2 will be non-zero. V3 will be non-zero. So if V2, V3 are non-zero, then Q2 will be non-zero. Q3 will be non-zero. What about this V1? This V1 will calculate this drop. To get that drop, I'll go for loop equation, plus minus, plus minus. Let's see that. V1 plus 1.5 into 6 minus 3 into 4 by 3 equal to 0. I'm going for loop equation. No guess, nothing. Start from here. Plus V1 plus 6 into 1.5 minus 3 into 4 by 3 equal to 0. 6 into 1.5. Anybody value this? It's a 3 by 2, 9, no? 9 minus, this will be 4. So what about the charge? Therefore, Q1 will be non-zero. Okay, you can, if you want, you can calculate V2. What is V2? V2 should be equal to 12 into C3 by C2 plus C3. C3 is how much? 8. 8 by 4 plus 8. 8 volt. So then Q2 equal to C2 into V2. C2 is how much? 4. 4 micro. This is 8. 32. In steady state, after closing K1 alone, the current drawn from the cell is how much I? Q3, anybody? Q3 will be 4 into C3. 4 will be 12. This will be 12 microcoulombs. Okay, this will be Q3. Okay, Q2, Q1, anyway, it's a non-zero, no? We have brought it. What are the conclusions we can make in steady state after alone charge in capacitor C1 is 0? C2, C3, we are getting different values, huh? 8 and 4. Check calculation. I think we are. So this I think current is I'm right. The values. Okay, we'll do one thing. 18, no? So 12 by 18, 2 by 3 ampere. Okay, so some problem is there here. 2 by 3 ampere. Okay, this is correct, no? 3, 6. So this will be 12 by 9. 12 by 9 will be 4 by 3. Okay, there's no problem. Okay, let's check once again. No? B1 will be 6 into, so this will be 2 by 3 minus 3 into 4 by 3. So this will be 3, 2. So this will be 4. Okay, this will be 0. Huh? Okay, there's option I'll pick up. In steady state, after closing K1 alone, the charge in capacitor C1 is 0. Okay, this option is there. What about B? Check calculation. 12 into, okay, this will be C3 is how much? 8 by 4 plus 8, 8 volt. 8 volt means, okay, this is C3 into V3. Huh? C3 is how much? 8. This will be 4 only. These options, option B is not there. In steady state, after closing K1 alone, the current drawn from the cell is. How much it will be current? 2 by 3 plus 4 by 3, 2 ampere. Yeah. Option A and C I'm picking up.